Hi everyone, and thank you for joining today's online training session. My name is Simon Grandin, and I'm the photogrammetry specialist here at SimActive. Today, I'm joined by a guest speaker from Wingtra, Andrea Nader, who's a customer success engineer at Wingtra. The topic of our online training session today will be how to perform high accuracy drone mapping without GCPs. These days, PPK and RTK UAV systems are getting much more popular um, with the high demand of high accuracy data. So today we'll talk about how to manage those types of data in order to have really high accurate data without using any GCPs in your project. So the topic of my presentation will be the following. We'll start with Andrea, and she'll talk about mission planning with WingtraOne, and also about data acquisition and post-processing data with Wingtra UAV. After that, I will bring you in Correlator 3D, and I will talk about performing aerial triangulation with PPK UAV data. I'll do a quick overview of the software, but I'll insist more on the aerial triangulation since it's quite an important step. After that, we'll talk about how to generate a DSM, DTM, and ortho mosaic in Correlator 3D. And finally, we will see how to assess the final accuracy of your mosaic. So let's start now, and I'll give the presentation to my guest speaker, Andrea.
Thanks a lot, Simon, for the introduction and for having me as part of the webinar. I'm happy to talk a little bit about how to plan a flight and to acquire the data that enables you to map highly accurate without using ground control points. I will do this by first introducing the company Wingtra to you. Then I will talk about what is required for high accuracy mapping and show you what to pay attention to when planning a flight. Then I will show you how a flight can be done and also how you acquire the base station data and how you do the geotagging. So let's start with Wingtra. The company, it was founded in 2016 with the headquarters here in Zurich, Switzerland. We have a local presence in North America, China, and Eastern Europe. We are world's leading VTOL drone producer. Our drone, the WingtraOne, is a professional VTOL drone that is mainly used in surveying and mapping. By now, we're 80 dedicated Wingtronauts. So what does VTOL mean and how does that work? As you can see here, the VTOL stands for vertical takeoff and landing, which means the drone takes off like a helicopter and then transitions into forward flight and to map the whole area and then transition back and hover down for the landing. So this enables you to take off from literally everywhere, and at the same time, you're capable of mapping really large areas very efficiently. So what does the VTOL technology bring us? So taking off vertically means we're landing and starting on the tail, and this enables us to carry high quality sensors, and because they're well protected during the start and landing. So we have a very high accurate camera that gives you brilliant resolution and a PPK module that allows to geotag the images also accurate, with a high absolute accuracy. Furthermore, due to the forward flight, you get large coverage, which in our case means you get with optimal conditions up to 55 minutes, which allows you to map an area of 400 hectares at 3 centimeter per pixel in one single flight. Furthermore, the system is fully autonomous and you don't need to interact with the drone. So this means it's truly safe and very easy to use. Today, the topic about high accuracy mapping without GCPs, I will mainly talk about the two first advantages. To start off, main is a high quality camera. The WingtraOne has different cameras integrated and they're easy swappable. For high accuracy mapping, we recommend to use the 42 megapixel camera with a 35 millimeter focal length and a full frame camera. This allows you to map with a resolution down to 0.7 centimeter per pixel. For other applications, also the Sony QX1 can be very useful. For example, if you want maximum coverage at a certain fixed altitude, you can get the maximum coverage with the QX1 due to the small focal length. Furthermore, we also integrated the multispectral camera from MicaSense, which is also provides very interesting applications. So besides the camera, you need a really high accurate, high quality PPK module. In our case, we use a dual frequency antenna from Septentrio. And this allows you, it's integrated directly above the camera to have the highest accuracy of the geotags. And we did several tests with the system and at different locations, and we processed the images afterwards and got overall an average RMS error of 1.3 centimeter in horizontal direction and 2.3 centimeter vertically. Simon will also present you one of the flight data afterwards to show you how to process these data. The PPK module is now available for the RX1 but also for the QX1 camera. So this was about hardware requirements to get high accuracy maps. Now I want to talk more about how do you actually plan the flight. And for this purpose, WingtraOne comes with a tablet which has the flight planning software WingtraPilot pre-installed. And this is easy to use on the field from the tablet. So to plan your flight, you need to define the area which you want to map. And you also need to define the ground sampling distance. So this is a very important factor because it's directly linked to the accuracy you want to achieve in the end, because you're not able to have measurements smaller than than the resolution. So you want a really small ground sampling distance if you want to achieve high accuracy. Besides the GSD, you can also change the flight direction. This allows you to minimize the flight path and you get the optimal flight plan, and you can most efficiently cover the area you want to map. Furthermore, the side overlap and front overlap is also very important. Here with the RX1 camera, the high resolution camera, we achieved very good maps down to 60% side and front overlap. And But if you map complicated structures, 3D structures, or you have a homogeneous area with, for example, forest that is also moving, we recommend to use more side overlap. Furthermore, you can also import a KML, and this allows you to really map the area which you require or which your client requested. And for accuracy, also very important is terrain following. WingtraPilot has an elevation model already installed or included, and this allows you to have every flight line has the corresponding height above the ground relative to the elevation model. This guarantees that the final map will have the required accuracy, so the GST is more uniform. And how to actually fly. This part is rather easy. So the WingtraOne or WingtraPilot has a checklist which needs to be fulfilled. So once all checks are green, it means the system is ready and you can start the flight from the tablet. The whole mission is fully autonomous, so you can just watch the flight and observe the flight progress from the tablet. One trick or tip, it's the camera is a passive sensor, so you want to have daylight, and the optimal conditions are if you have a bright day but cloudy, because sun will give reflections and also it can produce large shadows which will give images with very dark areas. So optimally you fly on a cloudy day, and if you have sun, fly in the middle of the day. But here also it depends highly on the camera. So for the RX1, R2, it is a very high quality camera and you can achieve really good results in a wide range of light conditions. So this was the part about the drone and the flying. Now, to get the absolute accuracy, we require a reference station, and so to get the correction of the geotags. And for this purpose, you need a survey grade base station. It can be, if you already have one, you can use your own base station, or you can also subscribe to any course or VRS service. And these are services of pre-installed base stations and which provide you the correction data. Important for the requirements for the base station, it should measure multiple frequencies and also multiple constellations. So with the more constellations the base station can measure, the more satellites will be measured, and this gives more reliable results. Furthermore, we recommend to use a logging interval of 1 second. You will be able to get results up to 15 seconds logging interval, but for optimal accuracy, we recommend to have 1 second logging interval. So when setting up a base station, so this is required if you use your own base station. If you subscribe to a network, then the coordinates will already be known. But if you set it up yourself, you need to make sure that the position you set it up, you define it very accurately, or maybe it's already known, a known point, which is marked on the ground. So, and also very important, the correction data or the base station logging needs to be longer than the flight duration, so that the entire flight is covered by the base station. Furthermore, the distance to the flight area from the base station is an important factor for the final accuracy. So you want to make sure that the base station is as close as possible to your flight area. And we can roughly say that every 10 kilometers you will lose 1 centimeter of accuracy. And also that height difference from the base to your flight area, it's also very important for the accuracy. With any GNSS measurements, it is always very important that you have a clear view to the sky. So make sure to place your base station not close to a high building or a mountain. And this will allow you to have a clear view to many satellites with also a wide angle to the satellites. When measuring with GPS, with GNSS receivers, it is always measured in a global defined coordinate system. So it's an ellipsoidal coordinate system that is it's a Earth fixed and Earth centered coordinate system. And on the other side, the surveyors, their final results, they will be needed in projected locally defined coordinate systems. So here it's very important to get high accuracy. It's also important to do this transformation very accurately. And especially when doing your first project or with a new coordinate system, we recommend you to use a few checkpoints. This will allow you to make sure that you have entered all correct settings in your post-processing software and that the transformation of the coordinates was correct. And when establishing some checkpoints, make sure to measure them very accurately and that they're also easy visible from the sky. So to sum up the requirements for the base station, so set up your base station on accurate defined coordinates, minimize the distance between the base station and your flight area, stay away from large objects that interfere with GNSS signals, and be careful with coordinate systems and establish accurate checkpoints. When you have the flight data, so you have the images and the GNSS data from the flight directly saved on the SD card of the camera after the flight. And besides that, you have base station data. So you have a RINEX file from either your own base station or a service or network. And you need to input this data into WingtraHub, which is our geotagging software. And what you get out is you get precisely geotagged images and the processing report, which the geotagged images can then be used with any post-processing software such as SimActive. Now, if you want to learn more about either our accuracy proofs or about how WingtraOne flies, feel free to visit our homepage. Thanks for listening.
Thank you very much, Andrea, for this nice presentation. So now I will talk about how processing such UAV data in Correlator 3D. So I'll talk a bit about how performing the aerial triangulation in Correlator 3D, what object or what elements you should look at it when you analyze your quality report once your aerial triangulation is done. I also talk a bit about the elements that are important for the aerial triangulation, such as the overlap and the image content or quality of the images. And then I'll jump to the generation of a DSM, DTM, and then assessing the final accuracy of your MOSAIC. So the optimal workflow for processing PPK UAV data is quite simple. So the first, once your project is created, you will have to extract the tie points between your images. The software will try to find common features between all your images to build a big block of images in order to have one block and then be able to match those images to generate some elevation data and generate some ortho photos. If you want to assess your accuracy of your aerial triangulation, you will need probably checkpoint. So you will have to tag your checkpoint in your project and then do your bundle adjustment, which will refine the parameters of your camera and also the angle of your IMU, such as the omega phi kappa of your system. Once you have a good solution for your aerial triangulation, you'll be able to extract a surface model in a raster form or in a point cloud, depending on your needs. From this surface model, Correlator 3D will also be able to generate a terrain model, and you could also, if you want, edit your surface model or your terrain model to also have better result or result that are up to your needs. Once your elevation data is good regarding your needs, you'll be able to perform the ortho rectification of all the images of your flight, and then generate a seamless mosaic with all the ortho photos. You'll also be able to edit or to play with the radiometric values of your mosaic and also play with the seamline editing with your mosaic. So, how to perform aerial triangulation with PPK data? In Correlator 3D, we have different mode to process UAV data, but for PPK data, the most important thing is when you import your images in the software. So when you create your project, you have to be aware that your position that you allows for each images, so each exterior orientation for the images need to be post-processed in order to have high accuracy data. So the exterior orientation that you will import will be the one that will be done after the geotagging of the images. You would also be able to play with the calibration of your sensor in order to eliminate all the radial distortion of the camera. If you want to assess your accuracy of your aerial triangulation, you will probably need to use some checkpoints. There's two different types of ground reference. There's what we call the ground control point, which is traditionally used in survey, which consists of tagging points in your images with precise coordinates, and they will be used as reference to adjust your block of images during the bundle adjustment process. The other type of ground reference is checkpoint. So the checkpoints are there not to calibrate your bundle adjustment, but they're there to validate the accuracy of your bundle adjustment. So they're not used during the calibration of the bundle adjustment, but they are there to assess the final accuracy of your aerial triangulation. And also, I will talk about interpreting the quality report, specifically with the WingtraOne project that we did not so long ago. So let's jump into the software and see how it works. So right now, what you see is the graphical user interface from Correlator 3D, which allows the user to produce is a result in two different ways. We have what we call the one-click button solution for users that are not too familiar with the photogrammetry process. And then it allows you to generate in a one-click button all the steps that are required in order to generate all the results you need to have. So we'll go from the AT to the DTM and the DSM extraction, also the ortho rectification and the mosaic creation. If you want to learn a bit more about the automated workflow, I suggest you take a look at the webinar we did on this particular subject in our learning section from our website simactive.com. The other way to process a project in Correlator 3D is to go step by step. So doing each step manually and really focus on the results you're getting out of each steps. Because it's really important if you want to generate high quality data to really go step by step and really look at the output you generate in each step, because they really have an impact on the next step that will be generated. So first, you will have to take a look at your quality reports, because it will have a great impact on the ortho rectification, but also on the DEM generation. You will also want to probably edit your DEM or take a look at your DEM or surface elevation, because it will have an impact on the ortho rectification and on the DTM extraction. And you also want to take a look at the individual orthos that are generated, because they will have an impact on your final mosaic accuracy and on the color balancing that you will be able to extract from your images. So the first point I would like to talk, it will be about the aerial triangulation. So in the aerial triangulation module, once it is open, you will have all your block, and then you will be able to find tie points between your images. Once the tie points between your images are found, you will be able to perform your bundle adjustment. So if I show you the quality report that could come out of your aerial triangulation data. Once your aerial triangulation is done, we generate usually what we call a quality report. It's a report that assessed all the parameters that will be used during the bundle adjustment to make sure that your aerial triangulation is well performed in your project. So on the first pages, basically what you have is you have an overview of your project. You will also have a report that will tells you a bit more about the relative accuracy of your project. So how well your tie points are between your images, and how well your block of images is well reconstructed. To assess the absolute accuracy of your project, we have two blocks that assess this accuracy. The first one is the ground control points, if they are used, and the other one is checkpoints. So the checkpoints have here a number of statistics, such as the average planimetric error, and also the average vertical error, and the projection error in pixels. Once you go down further in your quality report, well, you have all the parameters that were selected during the bundle adjustment project. So during your bundle adjustment, you will have here to unconstrain the calibration of your sensor, because you will need to let the software play with the parameters of the camera, and it will allows you to have a calibrated sensor at the end of the project. So the software do its own calibration of his camera. Also, we will play here with the adjustment of the exterior orientation of each images. So the X, Y, Z, omega phi kappa values of each images. When you process PPK data in Correlator 3D, well, we use the direct georeferencing option, which tells the software not really to optimize the position in X, Y, Z, but mostly focused on the angles of your project, such as the omega phi kappa. This allows us to find the best solution possible in order to have the great accuracies possible. So as you can see here, we have basically the solution before the bundle adjustment, with only the tie points are extracted, and there's no adjustment that's done on the camera and also on the angle of the images. And once your bundle adjustment is processed, well, we see that mostly all of your images has a really low residual, which tells us that the relative accuracy that we have for our block is accurate. We'll also tell you the average adjustment for each parameters of the block, and then the calibration that has been applied on the camera in order to eliminate the distortion from the geometric distortion from your camera. Finally, if you want to take a more closer look on your control point analysis, well, we offer much more specific statistics on your checkpoint or control point. In this specific project, we have used checkpoints because we only want to see, we really want to assess the accuracy of the geotagging of the WingtraOne images. And with the result that we got, so means that the checkpoint were not used to calibrate the bundle adjustment. Well, we could see that we have achieved a really high accuracy, which means that we have a planimetric accuracy of 1.2 centimeter and a 3D error of 1.9 centimeters, which is quite low. Also, here you have the information for each individual checkpoint. So you have their error in horizontal, so in X and Y, also in vertical and in a 3D direction. And also you have the error of tagging, which is in pixels. Finally, you also find the information of your system that will be used for processing your project. Once you're satisfied with your bundle adjustment, you'll be able to extract a precise surface model and also a terrain model. If you want to generate a surface model in Correlator 3D, well, in Correlator 3D, we worked in the raster form. So our first output will be a surface elevation data that will be extracted in the raster GeoTIFF format. And if by optional, if you want, you could also generate a point cloud at the same time. By default, Correlator 3D suggests you generate your output at 5 times the ground sample distance of your images. So let's say if you have a GSD of 1 centimeter, well, the optimal resolution will be 5 centimeters. However, with such data like WingtraOne data, you could probably lower a bit the resolution and go maybe to 3 times the ground sample distance and add a sharpness in your output and really have the best quality data possible. If you go lower than that, such as a pixel value like a 1-to-1 matching, you maybe add a bit more noise to your project. So we don't really suggest going below 3 times the GSD of your images. One thing that you really need to be aware is the resolution of your DSM will have a great impact on your processing time. So you really need to ask yourself before starting your project, what is the resolution I need for my project? Do I really need something at high resolution, or I could go something maybe a lower resolution depending on my client's needs? So this is questions that you probably need to be aware before starting your flight and even your processes. Um, so really have a reasonable value for your surface model generation. From this surface model, you'll be able to extract a digital terrain model. So Correlator 3D has um, an automatic tools to extract a digital terrain model from your surface model, which will look for elevation changes and the steeps of those changes, and try to identify elements that are not relative to the ground, such as trees, houses, buildings, cars, and stuff like that. Also, or if you want to have much more control on your result, you could also do post-processing on your terrain data or surface data to obtain better result. If we go in the software and see how does it look, well, we have here a surface data that is generated here at 5 times the ground simple distance of the project. So you'll be able to see that this project was mostly flat, so there's not too much challenge for photogrammetry, but with really high quality data, well, we were able to perform such nice surface model. So you'll be able to see that all the trees and the buildings were mapped, and from this surface elevation data, you'll be able to extract a terrain model which will remove such buildings and trees and will give you something like this. It will give you a flat terrain data with all the buildings and the trees that were removed. Also, if you want to edit your result, well, you could use our DEM editing module, such as you could draw some polygon over some elements. So if I only want to delete this building, well, I could generate a polygon over this building like this, and have the building remove nice and easy like this. So I could do some manual editing on my elevation data and remove only features that I need. You could also, by drawing polygon, do some editing, or you could also draw polygons and then use them as an exclusion zone, which will tell the software not to generate a DTM out of a certain section. Now, once you have generated your surface model and your terrain model, well, you'll be able to generate a mosaic from the individual orthos. So the first step will be to generate each ortho photos together. So by generating ortho photos, you'll be able to do it either on your surface model and on your terrain model, depending on your needs. So you'll either have a true ortho or a classic ortho. And then you'll be able to generate a mosaic out of this. If by any chance or sometimes you have one or two images that are problematic, which you had troubles with your lighting condition, you can you could select only specific images if you want to generate a sub part of your ortho. And you could also color balance your mosaic with your ortho. One thing that's quite important if you want to know a bit more about generating the mosaic. Well, I suggest you take a look. We did a 1-hour webinar on how to generate accurate ortho and mosaic with Correlator 3D. That's available on our website. So if I looked in the software, well, we first see when we generate the orthophoto process that the software will generate one single ortho for each images that was taken. So this means that at this step, all the deformation caused by your terrain and your camera distortion are all removed. In this case of the project, I decided to use a terrain data uh, instead of of a surface data. So in the orthos, all the parallax of the terrain limit has been removed, except from building or trees, because it usually gives much better visual results than a true ortho. So from those individual ortho, you'll be able to create a seamless mosaic with color balancing. And also, you'll be able to only use the more nadir part of the imagery if it's something that you want to use. So in the mosaic editing module, you'll be able uh, to load your mosaic like this. So it's a seamless mosaic that was generated, and by selecting your block, you'll be able to generate or to edit the same line of your project. So we quickly see that all the seam lines are the lines that were used between two images to generate a seamless mosaic. So I will be able to edit one seam line like this. So click on it like this, and only edit certain parts of the mosaic in order to have also better results if I want to have sharper results. Finally, once your mosaic is generated and you really want to assess your mosaic accuracy, well, you could validate the result with the checkpoints. So you will be able to pan into your mosaic and quickly see that all the process or all the outputs that were generated are really well tied on the checkpoints of your project. And also, you'll be able to assess the radiometric quality by looking if if it's a uniform color over your mosaic. You'll also be able to edit the radiometry of your mosaic depending on your needs. So if I go in the software, you'll have on your mosaic, you'll be able to pan to your mosaic. And as my checkpoints were previously marked, if I zoom in onto a checkpoint, well, I could quickly see that the checkpoint is really well in the center of my checkpoints. So I could do this for a few checkpoints. So a visual assessment accuracy. And then I could go over all my project. But this usually, when you have a really high accuracy from your quality report, should be matched. So your checkpoint between your mosaic. If not, you may want to go further back, probably into the DAM extraction, and try to see if there's something that was not properly done, or if you have any modification to do. The great thing with Correlator 3D is if you want to go back into previous processes, well, it's really easy to reprocess an elevation data and then ortho right after. And it's much more faster than our competitors because our main advantages is the speed of the software. So we're usually 3 to 5 times much faster than the competition. Also, in your mosaic, if you want to assess the radiometric quality of your mosaic, well, you could adjust the histogram of your mosaic. So you could stretch the histogram. So I could stretch the input histogram like this. And then playing with the color, I could also preview it before and after. Also, you could adjust individual band from those. I could adjust the red band, the blue band, the green band, depending on your needs. Also, we could generate, depending on the camera you have, if you have a multispectral camera, we generate vegetation indices such as NDVI and other vegetation indices like this. So finally, last thing I would like to tell you is probably the unique benefit that Correlator 3D has on the market. So we have unmatched processing speed because Correlator 3D is a graphical power-based software. So we're mostly focused on the GPU component of your computer, even if we use the CPU of your computer. Most of our customers, all they really need is probably a good hard drive, such as a SSD drive, and a good graphic card, and you're good to go for big photogrammetric processes. No training is required because we offer multiple solutions, such as the automated workflow with the one-click button, or for much more advanced user, we could go process by process and really take a look at each output that generated in order to have the best output possible. Also, we can have project of unlimited number of images, and they could be processed on a single standard PC. We have some customers that process images of 250 megapixels, and they have around 30,000 images. So you could assume that it's quite big project. Also, we could have a cloud integration, so the software could be installed on instance like Azure or AWS. And we also offer a command line interface. So we have a whole range of a scripting process that allows you to have scripting tools and really automate all your workflow. And finally, if you ever had any questions with our software, feel free to contact us. We're there to help you in order to achieve the best result possible. I would like to finish this webinar by letting you know that we have free trials that are available on our website. So we offer a possibility to try the software for a period of 14 days, which the link is available on our website. Also, feel free to contact us if you have any question regarding Correlator 3D, or you could contact NGI if you have any question regarding WingtraOne UAV. I hope everyone enjoyed this webinar, and thank you for attending this online training session, and I hope you have a great rest of the day.